Next up, this team of UCF students is representing UCF in the ASHRAE selection competition. They are selecting components for the hospital Ginsburg Tower. Please welcome the ASHRAE selection team.
We're the ASHRAE selection team, and my name is Brian Oz. I'm a mechanical engineer doing the energy systems option. And over here we have John Stischak. He's also a mechanical engineer doing the energy systems option. We have Larry Stoff, who is a mechanical engineer doing the energy systems option. And also on our team we have Seth Tila, who is a mechanical engineer doing the materials option. I'm going to tell you a little bit about what ASHRAE is and what they do. First, ASHRAE stands for the American Society of Heating, Refrigeration, and Air Conditioning Engineers. The society was founded in 1894, and today it consists of about 51,000 persons worldwide. It is responsible for setting the standards and advancing the HVAC industry. ASHRAE promotes a sustainable world by promoting research, writing standards, and publishing and continuing to educate the 51,000 people within the organization. ASHRAE is important because buildings make up a large part of the energy consumption in the United States. 40% of the primary energy use is used up by buildings. Also, 72% of the electricity consumption is used up by buildings. 39% of the CO2 emissions are consumed by buildings. Almost 14% of the potable water in America is used by buildings. ASHRAE helps to maintain those numbers by regulating standards and also helps to regulate indoor air quality throughout the buildings. People spend a lot of time indoors in America.
All right, the 2010 Senior Design Selection Project. Obviously, this is something that's done every year. It's an international competition. It includes designing and selecting the HVAC systems for a different building every year in a different city. Luckily this year the building was selected in Orlando, which was the Florida Hospital Ginsburg Tower. It's a huge building, really kind of a bear to design, but it was a great learning process. It was 675,000 square feet. It consists of lots of multiple use space. We got cafeterias, ERs, gift shops, lobbies, diagnostic imaging, AI patient rooms, all that stuff. For our particular project, our objectives were obviously to design and select a cost-effective, efficient, and fully functional HVAC system for the Florida Hospital Ginsburg Tower. And the key components we really tried to focus on was life cycle cost, environmental impact, as this is ASHRAE. We're trying to make everything more energy efficient and kind of more sustainable. Comfort and health. It is a healthcare facility, so obviously a lot of the operating rooms and things like that need special attention, especially with controlling the air, because you don't want someone with an open wound or maybe having surgery to have dust or any kind of airborne illnesses in the air, so we got to monitor that and really design around that. We wanted to pay attention to creative green design, and of course, if you looked at the slide previous, it had a nice picture of the Florida Hospital Ginsburg Tower. It's a beautiful building, and we really wanted to make sure we kept synergy with architecture on the top of our heads.
Our team approach and goals was to first model the building in Train Trace 700 and run full energy calculations. We used energy guidance to make good decisions, along with ASHRAE Standard 90.1, which sets the standard for energy consumption for buildings, to create our base model, and then improve from that model with other systems. We looked at 4 or 5 different combinations of systems and equipment, including variable air volume systems, water-cooled and air-cooled chillers, along with various other components. We turned out that the system that we ended up going with, there were 2 systems we ended up putting in the final running, were water-cooled chillers using energy recovery, and also a tri-generation system by producing power with
Gas turbine.
Yeah, gas turbine gensets. Thank you. Excuse me. We also need to provide a 20-year life cycle cost. This is very important because we had to provide proper payback times for these systems. We didn't want to put in a very expensive system and not be able to make the payback time. We actually found out some very interesting key components as we were going through this. initial cost, energy consumption, maintenance cost, and operations cost all considered. And if you'd like to find out our conclusions about the rest of this, please meet us back there at our table, back at table 15, and talk to us further, because we found out some very interesting things with the energy we're actually able to sell back to the grid. And we'd also like to wrap this all up by saying special thanks to everyone who helped us out. PBS&J, Peninsula Engineering, Harper Lillenbach, Progress Energy, of course, Stan Weaver Company, Johnson Controls. There's many more that we can't even list. Our advisors here at UCF. I appreciate it very much, and thank you for having us here today.